Welcome to another segment of High School Geometry with Netz and Weichel. This is Mrs. Netz.
And this is Mrs. Weichel.
And today we are covering 7.4 Contextual Problems. What does that mean we'll be doing? Well, that means by the end of the lesson, you will be able to determine a missing piece of information given a real-life problem using what you learned in 7.1, 7.2, and 7.3. Why do you need to know this? Well, these angles are useful in determining the height and distance at which an object is located and are commonly used with satellite technology such as GPS. And to be honest, no one in the real world is ever just going to hand you a math problem. They're going to give you a real life problem. So, how will you know it? You'll know you mastered it when you can find a solution to a real world problem that makes sense.
So let's get started. So the first problem, I gave you a cute little picture demonstrating what the problem is talking about. You have a ladder that's creating a 56-degree angle with the ground. How far is the base of the 12-foot ladder from the base of the house? You're going to approximate to the nearest hundredth. So what you guys have to do is take the real world almost out of it for a moment and remember what we're doing in this unit. We are doing right triangles, so you have to locate the right triangle within the picture. Well, the ladder, the ground, and the house are forming your right triangle. And then you can label where the 56-degree angle would go and the 12-foot would go.
Now think about this. It says that it's going to create a 56-degree angle with the ground. The ladder does. So it's where the ladder meets the ground where you're going to see the 56-degree angle. Also, it says it's a 12-foot ladder. So that means the ladder itself is 12 feet long, not that the height that the ladder hits the house is at 12 feet. The ladder is 12 feet long. So that should help you label. Now we want to know how far is it from the base of the house. So the base of the house is the ground. So how far away is the ladder from the ground?
So the next thing we need to do is determine what method we're going to solve. So far we've learned Pythagorean theorem, trigonometry, inverse trigonometry, and then special right triangles. Because of the information I have, this is going to be a trigonometry problem. So we're going to use SOHCAHTOA. The next thing you guys need to determine is which trigonometry ratio are we going to use? Will it be sine, cosine, or tangent? Well, based on the 56-degree angle, where x is, which is adjacent to the 56 degrees, and where the 12 is, which is my hypotenuse, this becomes a cosine problem. So we're going to write cosine of 56 degrees is going to equal adjacent over hypotenuse, so it's going to be x over 12. And then from here you would just go through and solve this just as we have been solving them in this unit. So you would treat this first one as your proportion. We would cross multiply, and 12 ends up multiplying with the cosine of 56, which ends up being this decimal. I gave 3 decimal here so that you could see what it would round to. The 6.710 would round to just 6.71. This is a word problem, so give me words for answers. So we would say that the ladder, the base of the ladder, is about 6.71 feet away.
Actually, I think you probably just tell somebody it's about 7 feet away, to be honest, because I don't know how many of my friends understand 0.71.
True.
Sadly, only my math friends really understand that.
All right, next. The blades of the desk fan are perpendicular and congruent. The distance between the consecutive blade tips are 8 centimeters. Find the length of each blade.
So let's find a triangle.
So we need to make our right triangle. So if these are perpendicular, that's a vocabulary word from earlier in the semester, we know that that means that the blades are making right angles. We also know the distance from the end to end is going to be 8 centimeters, so we can go ahead and make our right triangle. Oh, and we know that the blades are congruent to each other, so whatever this one is, so is this one. So this could be Pythagorean theorem, it could be trigonometry. I am going to solve it as a 45-45-90 triangle because this is an isosceles right triangle. So I'm going to review those pointers. So 45-45-90 only has 2 different angles and 2 different side lengths. So this must be my ratio with square root of 2.
This is going to be easy.
Because the hypotenuse is given, I need to go to the smaller leg, so I am going to use the square root of 2 by dividing it out.
You know you're going to divide because we're getting smaller.
Exactly. We cannot reduce this because order of operations says I need to solve the square root of 2 before I can divide it by 8. Because we can't solve that, we're going to rationalize our denominator, which gives me 8 square root 2 over 2, which reduces to 4 square root 2. And then if I figure out what that is, I would get that each blade is about 5.66 centimeters in length.
Perfect. Let's try another one.
And then the last one on the front side, you have a square grassy area. It's 50 by 50. A caretaker of the park is going to be putting in a sidewalk connecting the northwest corner to the southeast. So if you know your directions, here's north, east, south, and west. So we're going to start on the northwest corner and go to the southeast, which would form 2 right triangles. We're looking for the distance of the sidewalk, which would become the hypotenuse. So once again, this could be Pythagorean theorem. You could do trigonometry, or you could use your special right relationships. I like to practice those because I think they are the easiest if you know them. So when you have your 45, 45, 90, again, 2 different side lengths, 2 different angle measures. So this is the square root of 2, 1. Because we're looking for the longer side, the hypotenuse, you are going to multiply your leg by square root of 2, and there is your answer. Plug that in your calculator. You get 70.710. So therefore, the sidewalk would be about 70.71 feet in length.
Excellent.
All right, we have a vocabulary word. Angle of depression. An angle of depression is the angle between the horizontal and the line of sight to an object when looking down at something. So again, I like my little pictures here. We have a little man. He's floating a hot air balloon. If he were looking straight out, he would be looking along this horizontal line.
That's called his line of sight.
But then he changes his line of sight and is now looking at the horsies that are down at the bottom.
So now he has a new line of sight.
So I have a bunch of stuff you can add to this picture. Your horizontal is the horizontal line that he would be looking at if he was looking straight. The line of sight now is what is connecting the object at the top to the object at the bottom. This is our line of sight. The angle between the two is going to be your angle of depression. It is when you are looking down.
Mrs. Weigel, this looks a lot like an old lesson, like a lot like. Don't you kind of see parallel lines cut by a transversal?
I do. If you have a horizontal here and the ground provided it's horizontal, you would definitely have parallel lines cut by the line of sight transversal. Yes.
So we know a lot about these angles
So
here.
we do.
Interesting.
All right, and then something else. Okay. So you guys have a fill in the blank. Sorry, I just clicked ahead. Just pointing out what the line of sight is. The line of sight is the imaginary path that your eyes follow when looking at something. So when you are looking at something, that is your line of sight. So the little binoculars connecting to the horse is what you're going to fill in there.
Fill in your blanks. The angle of depression is the imaginary path that your eyes follow. No?
It's the line of sight is
you're
the imaginary
right.
path that your eyes follow when looking at something.
Got it. All right, here we go.
All right, so now we're going to actually see this problem show up or this vocabulary word show up in a problem. So the mouse dug a tunnel at an angle of depression of 28 degrees. It's very smart.
That is a smart mouse.
He knew what that angle of depression was. The tunnel is 0.75 meters in length, so 3/4 of a meter, and then it's going to a small den at the end. How far below the surface is the den? So again, you guys need a right triangle here. So we have to figure out where the right triangle is going to be. So the tunnel is going diagonally down, and the ground, as we were just kind of talking, is sort of going horizontal. So we need a perpendicular line to that horizontal. It's going to be that depth, what we're actually looking for. So here's our right triangle. Your angle of depression is the horizontal ground to the line of sight. So if he was standing here and looking down to the den, this would be his line of sight. So here's our angle of depression. It's going to be right under that horizontal line always. It's almost the opposite of what you would think. So depression, you think down. So an angle of depression is actually at the top because you're looking down at something. And then it's asking for the depth. So this is the side you're looking for. So going through our thoughts, could I do Pythagorean theorem, trigonometry? Could I do special rights? Based on the information I have, this is going to be a trigonometry problem. From the 28 degrees, we would say that the side you're looking for, in this case x, is opposite, and the 0.75 is our hypotenuse, so the trig ratio we are going to pick is sine. So sine of the angle, 28 degrees, is going to be equal to opposite over hypotenuse, so it's going to be x over 0.75.
Now, since we have our variable in our numerator, we know we are going to multiply. So we're going to do x is equal to 0.75 times sine 28.
And when you plug that in your calculator, you get 0.352. Therefore, the tunnel is about 0.35 meters down.
Excellent.
All right, next vocabulary word.
Angle of elevation.
Basically the exact opposite of what an angle of depression is. So an angle of elevation is the angle between a horizontal, so it's the same, you have a horizontal line again, but now your line of sight, you're looking up at something. So you can see, I have the mirror image, I couldn't fit it on my screen very well, so I flipped it around. So you're looking at Winnie the Pooh, who is looking up at his red balloon. So right here is our horizontal this time. And then he, from looking straight, is now looking up at the balloon. So this is our line of sight. So the angle of elevation is going to be right here. As we were just talking about transversals and parallel lines, because both angle of elevations and depressions have a horizontal line involved, when you have both of these angles, they're always going to be congruent because they're alternate interior angles.
Exactly.
So sometimes the picture gives you one, but the triangle you draw, you use the other. They're always going to be equal. All right, so we have two more problems and then we're done. So this one, you don't have a picture, so you get to draw it. If you want to be creative, go for it. If you want to just draw your right triangle, go for it. It's up to you.
That's going to be kind of critical with a lot of these problems when you're working through them. If you don't have a picture, I would absolutely recommend drawing it. So that way you can label it and you can actually see what is going on.
Yes. So you have a building. If the building is standing up and built correctly, it's going to be vertical to the ground, hopefully.
I hope so.
The ground most likely is going to be horizontal. So horizontal, vertical, make your right angle. The sun is going to, the way the sun makes shadows, it basically hits the object, and the object is then the shadow on the ground. So the angle at which the sun is hitting the object forms that shadow. So
now I had some students ask me, but wait a minute, isn't the shadow the length of that red line that we have there?
I see that all the time.
And here's my reply. Where do we see shadows? On the ground.
Right.
So you would measure the shadow on the ground.
When you're standing outside, usually your shadow is connected to your feet, not your head. So our right triangle is going to show, here's our height, the building's 248 feet tall. The shadow is going to be along the ground at 275 feet. It is asking you to find the angle of elevation. Remember, an angle of elevation is going to be a horizontal line and then above it. So like I said, it's almost the opposite of where you think it is. Elevation, you think up, but it's going to start at the bottom then. So go to the opposite direction you think you're going to be in. So because we're looking for an angle measurement, that automatically makes this a trigonometry problem. When you label your O, A, and H, 248 is opposite the angle theta you're looking for. 275 is adjacent, and then this blank side is our hypotenuse. So because we're using opposite adjacent, that makes this a tangent problem. Because theta is over here on the left side, you would divide tangent out, which turns it into the inverse of tangent. And you plug that in. What's the magic button you got to hit to?
Shift. Hit your shift.
Don't forget
Everybody
to
hit the shift.
So shift tangent times 248 divided by 275 gives you a decimal of about 40, or I'm sorry, not a decimal, a degree of about 42 degrees.
Please remember, always, 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 regardless of what you get, your degrees or your angles will always be to the nearest whole degree.
All right, and the last problem. We have a 4-foot little girl. She's outside flying a kite at an angle of elevation of 30 degrees. The string, which ends at the top of her head, is 45 feet in length. How high is the kite above the ground? So we need to draw this lovely little picture. So I cheated. I used clip art because I'm not a very good artist. I'm looking at Mrs. Nett's notes. She drew. Hers is pretty good.
Yeah, I got a lot of slack on my kite line.
So, okay. So an angle of elevation requires two things. It requires a horizontal line, and it requires a line of sight up to something. So if we were looking up, we would be looking at the kite. So the string actually becomes the line of sight, which means we're missing our horizontal. So we need a horizontal line. So it's going to come right here. And then we need to go straight up. So that's going to give me this. The 45-foot string, the 30-degree angle of elevation, and we're looking for the height.
Wait a minute.
We're right
30-degree
here.
angle.
So you could use trigonometry. This would be a sine problem, but I am a fan of special right triangles. This
make
must be a
math
30,
so
60,
easy.
90
Yes,
triangle.
do it.
So that's what I did. And it's even easier because you're given the hypotenuse.
Yes.
You're looking for the short leg.
Yay.
So all you have to do is cut 45 in half, and you get your answer
Easy.
of 22 and a half. Now, there is one catch to this.
Wait, we're done.
We're close to done.
Oh.
Close to done.
What did we forget?
Based on the clues in the problem, we are told that the end of the string is not ending at ground level. It's ending at the top of the girl's head, and we know that the girl is 4 feet tall.
Oh, they want to know how far the kite is from the kite to the ground.
If you notice the picture we drew here, the triangle is almost like floating above the ground, and we know it's floating at 4 feet above the ground. So we have one more thing we need to do. We need to factor in the fact that we are 4 feet above the ground. So our answer we got of 22 and a half needs to be added to that 4 feet, making the kite about 26 and a half feet above the ground.
This is almost like that bunk bed problem.
It is totally just like that. All
Crazy.
right.
All right.
So that is it. Hopefully you can choose the best method. I'm a huge fan of special right triangles, as you can see. Yeah.
And if you would, make sure you turn to page 36 as soon as you're done watching the video and see if you can label or describe the angles of elevation and depression based on the two pictures.
So you have 8 angles. The first one is done for you, and which is basically showing you the expectation of what we want to see on lines 2 through 8.
Easy.
All right.
Oh,
If
and
you have
don't
any
forget the
problems,
homework.
message us.
Yeah. Oh, Mrs. Weichel.
Yes.
Mrs.
Nett.
Do you know why the equal sign is so humble?
Why?
Because it's not greater than or less than anything else.
Oh, that's so sweet.
Okay.
Thanks for joining us. We have one more lesson to go in this unit.
7.5 radians.